I am recording now. Quick fun fact before we move on. Onshape added this really cool feature called variable tables. And so I probably won't be using this for this robot, but this is definitely something you all might want to play with in the future. I've been using it a lot for my most recent CAD project, which is my 3D printer design. But what you can actually do is instead of importing like or instead of defining a specific length, you can actually create a variable by using the hashtag feature. So like, let's say I change this depth to hashtag left rail length, and then I insert the value as 20 inches. What you can actually do is down here on the right side at your variable table, you actually change this value to be whatever you want directly from this table. So I could say, make you 35 inches, you 50 inches. And so this is very useful if you ever like run into a situation where it's like, I have no idea what this distance is supposed to be, because it might depend on other factors. You can insert it as a variable, and you could easily change this variables later. Very useful if you're, designing parts that you don't necessarily know what the final result is going to look like. I just have been using that a lot since just yesterday, basically. So, fun fact. Cool. So we have created a 2x1 bar that is a 1/8 of an inch thick on all sides. This is going to be our left drive rail. So let us look at this bar. So we're going to ignore all the tiny holes. The tiny holes are used for basically lightning and also attaching stuff. We're not going to worry about those right now. We're going to worry about those later. The first thing that we're going to look at is we're going to look at this massive hole here on the front. They have a 1.5 inch diameter circle that is, if we measure it from the left edge, the center distance is 14 inches away, so it's halfway down the bar. And we can notice it's a little bit offset. That's just because this is the West Coast drive, so the center wheel is going to be dropped. And we can notice that it is, for a 2-inch bar, it has an 1/8 of an inch drop. So it's 1.125 inches down the center of the hole. So we're going to go ahead and model that. I'm going to create a new sketch on the left side of this bar here. I'm just going to drop a circle. I want to make sure that my circle is not accidentally grabbed. Like here, it's being grabbed to the midline. I don't want to do that. You can actually solve that by holding down Shift, and your mouse won't snap to anything. I'm going to drop down a hole. I'm going to make it 1.5 inches diameter. I'm going to dimension it from the edge, and I'm going to make that dimension 14 inches. I'm going to dimension it from the top, and that's going to be an 1/8 of an inch, 0.125. Holes. Cool. So hopefully you all are following along. We're just going to continue down the line and look at some of the other stuff they have here. So they have a rectangle, and the rectangles are at each end. I'm going to model this left rectangle first because I don't know if they are identical. I think they are. We will verify that later. So this rectangle is, first off, I could grab here, is 1.378 inches high. I'm going to go ahead and actually start modeling this. Cool. Don't know the length. It's 1.378 inches high, and the width of it is this inside is 1.725 inches. I'm going to edit this one. So a height of 1.378 and a width of 1.725. Plot that right there, and I'm going to check and see what is the distance from the top. That's what I'm going to get relative to. There's a parallel distance of 0.311. 0.311. Actually, what? 3.1. 0.311. And then we are going to mention it from the edge. It is weird number. 0.723214 inches. Doesn't really matter. I'm going to do about our purposes. We're going to do 0.725 inches. It past the second decimal point, it really doesn't matter. And we'll actually notice that the reason for this cutout is actually to give extra tolerances, so you can actually adjust the bar or adjust the wheel length later. So I'm gonna drop these dimensions as a screenshot into the Slack, just in case you all need them. I probably shouldn't have done that yet because we have to add a few more dimensions. As you notice, there's these little kind of arms off to the side, and we're going to model those quickly because those are clearances for the bolts that are going to go through here. So the hole is a 0.191 diameter inch hole, and that is quarter of an inch away from the edge of the bar, and I believe it is exactly halfway down the bar. 594, yeah. And that is modeled equally on both sides. So what I'm going to do here is I'm going to grab the midpoint, drop a little circle, 0.191. Okay, drag a line across holes. We've done this before. These lines tangent these guys. Make you quarter of an inch. Okay, trim the back end of you, trim you, trim you. Then, just to make my life easier, instead of doing that all over again, I'm going to make a construction line here, and I'm going to mirror this feature across the construction line. Trim you. I'm going to re-upload these dimensions. Front wheel up. Where do you call this? Bearing block. Any questions? Hopefully I didn't confuse you all too much. I mean, this is just simple sketches, so even though you might not understand what these dimensions are right now, they will make sense shortly. So, while you all might finish up that, I'm going to quickly check over here and see if this is any different. Oh. Oh. No. Okay, cool. So what we're going to do then, sorry, is I'm going to drop another construction line down the middle, and we're going to mirror this entire thing. If you click in the bottom right and drag upwards, we are going to mirror the entire thingamabob and to mirror everything as well. Okay, so now you should have your bar looking like this, and simply we are going to extrude. I'm going to click on that entire sketch, remove through all. I'm going to just call this left drive rail holes. This left drive rail profile. These aren't technically holes. What would you call these? Bearing cutouts. Just like naming those. There you have it. That is your left drive rail. And so the reason for these are the areas that your wheel shaft will go through. Um, so each of these houses what's called a bearing block because your wheel must always be supported by bearings. And your wheel on a West Coast drive, your wheels are on the outside and they have to be powered by a shaft that goes through the bar, and the shaft is actually powered on the inside because your gearbox is going to sit on the inside of the robot and then have chain running to the front and back wheels. That chain is going to spin the axle, and the axle goes to the wheel. Now, 1678 uses a specific type of bearing block, a type of bearing block that I actually haven't used in person before. Actually, just pull it up right here quickly. Highlight the hide other instances. Hide U3. U. And there we go. I discuss it as well. Yeah, they use these specific type of bearing blocks that are kind of weird. I guess they cut out a rectangle just because that was easier to machine. Yeah, because the entire thing is going to shift left and right. For Rosie, we actually used these clamping blocks that actually went over the bar. We used the Vex Pro, they call it clamping bearing block. See if I can find the exact ones. Yeah, we used one of these guys. Um, the VersaBlock, yeah. So we used one of these. These are pretty great because all you need to do is the bearings are held in by this block and they're kind of sandwiched on the inside by the bar itself. So these are on the outside of the bar, as you all will remember. So you only just needed to drill kind of like a simple hole in the middle. The disadvantage of these guys is that because they clamp over the bearing block, you actually get like the bearing block has to sit kind of up here, and you have a bolt that goes across. This bolt right here goes across the top of the drive rail. So if you wanted to lay anything down, let's say you had a mechanism or something that you wanted to mount right here, you couldn't because the bearing block got in the way. These, on the other hand, don't have that issue because they're being mounted through the aluminum tube. We'll see how they do that here in a second. But these are just a different form of bearing block. As you see, they still hold the bearings right here, and they're adjustable. That's kind of the key thing about these. They could be pushed left or right based on how much the chain stretches over time, which is something very important. You always need to make sure wheels are tensioned. So the only other thing to do is to add all these holes. I'm going to be completely honest, I don't care about this. The amount of effort that it takes you to drill all these holes is just, in my opinion, too much. And you're going to save like maybe a pound of weight. And if you're worrying about like a pound of weight, you have other problems to worry about. So personally, I do not care about machining all of these holes. It's just more work. But there is a Julia feature script that allows you to convert the tube, and you can convert it to the 1678 style if you just click on it. I was messing around with this yesterday, and the feature script has a glitch in it where, for some reason, because this hole is so low, it causes an error. If you make this hole smaller or you raise it up a little bit, it will put all the holes through it in a 1678 style pattern. But for some reason, with this center hole, it doesn't work. So I am not going to bother with adding in all of these holes because I think it's kind of worthless. We will only add holes in the parts that actually require them, which will be a few up here for a gusset. The remaining thing that we need to do is I do need to check where else we need holes. We need one for the cam. Let me me just check this quickly. One there. Check something on this wheel. It's been a while since I looked at how this works. Okay, so we do need a hole there as well. Okay, I'm gonna go back in. I'm gonna go into the sketch and I'm gonna add a few more holes. First, I'm gonna add a little hole over here, kind of, yeah, basically in the center. And this hole needs to be, let's check, let's look at this cam. I'm gonna make you transparent. Holes are all 0.191 inches. So I'm gonna make you 0.191. And you are transparent. It's not what I wanted to do. You and you. Transparent. So the distance from the center of you to you is, let's say 1/4 of an inch. It's a cam, it will be adjustable. So I'm going to put 0.75. And then I'm going to very quickly mirror that across the center line. Other side. Yep, there. And then we need to add 2 holes here around this center bar. I'm going to just do transparent. So we need a hole that is 15/16, 0.9375 inches away from the center. Yeah, that's it, because you can actually see that hole slightly offset from all the others. We need, guys, let's see. We're not going to mate it to anything just yet. It's going to be 0.191 again, I assume. Actually, double check that. Yep, 0.191 is going to be, I use a vertical mate, or sorry, horizontal mate. So make you horizontal with the center of this guy. I'm going to make the distance 0.9375, 15/16. I'm going to mirror that just because I'm lazy, the other side. And because I extruded the entire sketch, those should automatically extrude out. So your bar should look like this. Questions, if any?
What did the cam do?
Ooh, so the cams. Let's just I'll demonstrate this more in a bit. But I'll go ahead and explain it just for simplicity's sake. So, over time, your gears, or not your gears, sorry, your chains or your belts start to stretch. It doesn't matter which one you use. Chains tend to stretch more than belts, which is part of the reason I prefer belts. But basically, the linkages between your chains start to wear out and stretch over time. And each linkage will only stretch by maybe a hundredth of an inch. But the longer chain you have and the more linkages you have, the more and more your chain will stretch. And so what a cam does is the cam, as it twists around, you can take it, so it doesn't really do it here, but you can notice this like seashell type shape to it. So if you think about twisting the cam counterclockwise, the end of the cam is eventually going to push and touch the bearing block here. And the bearing block is, for the most part, free floating. It's clamped to the other side of the bearing block, and it touches the bottom of the rectangle we cut out. But there's nothing preventing it from sliding left or right. And so the chain, because the chain has a certain amount of tension on it, the chain wants to pull the bearing block inwards. It wants to pull the bearing block to the right, and with the bearing block, it will pull the wheel to the right. And the cam is there to prevent that. The cam is actually there to push the bearing block to the left so you can apply more tension to the chain and keep your chain taut. So that is the entire purpose of a cam, to push a bearing block away from the the other termination point of the chain, or the other sprockets. Capiche?
Yep.
It'll make more sense when we actually CAD it, but cams are great. You always need them. If you ever design a drivetrain, um, and you have long belt runs or chain runs, you always need a tensioning system, because it might work at the beginning of the season. You might design this and it'll work great, but then when you get to like district championships, your robot is gonna start, having skipping issues and other sorts of problems, unless you actually go in there and replace the chain, and that's just a whole ordeal. Um, it just wastes time. The great thing about this is you can just twist it at the beginning of every competition. You just make sure it's tight, and you're good to go. So let's try getting this done. So what we are going to do is we need to create a new assembly. We are going to create an assembly, and it's going to be called assembly 1 at first. We're going to rename it, and this is going to be drivetrain in brackets. So this is a higher level assembly. So gearbox was our A level assembly, but now gearbox is going to be demoted because the gearbox is actually going to go into this assembly. And I'm thinking I'm going to assemble this entire rail together, entire left drive rail. So this is going to be my new A level assembly. So eventually actually become a B level assembly, but we're not going to worry about that right now. So I'm going to call this drivetrain A left drive rail. And I'm actually going to go over here to the gearbox and demote this to a B level assembly, because again, B's go into A's. So what I'm going to do is I'm going to come over here and I'm going to insert my left drive rail, and I'm going to insert my gearbox assembly. These are the two things I need right now. Okay, cool. So once I have both of those, I'm actually going to go ahead and insert a bunch of other stuff that I'm going to need. Let's see, we are going to need, well, first, let's worry about anchoring this guy. So what are you called specifically? I've actually forgotten the name. This is a chamfer. No. This is a... Okay, don't give me the name for it. Look for it manually in the CAD parts. This is a... Go down to Versa. I scroll through. This is a West Coast Products gearbox bearing block. So we are going to insert a West Coast Products gearbox bearing block, one of those, and we're eventually going to have one of the side bearing blocks, but I'm not going to worry about inserting that right now. So this is the little guy that we need right now. I'm going to just orient it direction that I need, kind of over here. So that's eventually going to go right there. Right now, I'm also going to worry about what else do we need. So I'm going to make you transparent as well. So I'm going to need one standard flanged half-inch hex hex bearing. That's going to go inside of the clamp. And then I'm going to need a spacer. That is a custom spacer, so we'll make that here in a second. I'm going to go back into MKCAD. I'm going to make a bearing, or pull a bearing quickly. Bearings, we want the half-inch hex. Half-inch hex, 1 1/8 inch outer diameter flanged bearing. This guy. And I'm going to quickly mate this guy right into here. Perfect. Just rename that half-inch hex bearing. There we go. Now I'm going to insert this onto the outside of our drive rail. So I'm going to fasten mate for this little outer edge to go right there. And I'm going to rename this West Coast product gearbox. What is this called? Bearing block? Yep. That is that done. So now what we are going to do, we do need a spacer first. So we're going to go in and design that spacer. So if we think about this, this is going to go like, this is obviously going to go kind of straight through here. And the plate here will actually touch right there. So it's eventually going to look like that. Now, the reason we want to put a spacer in here is you got to think like, these sprockets cannot move to the right because they are anchored by not only the plate itself, but the shaft collar. Basically, if any lateral force to the right is going to be prevented by whatever shaft retention you use here, in this case an E-clip. So you cannot push anything to the right. But there's no reason that these can't slide to the left. Even if you had, let's say, you had your chain running here, these theoretically could still slide to the left. So we want to put a spacer in here and prevent that from happening. And if you put a spacer that goes from this to the inside of this bearing, that's going to stop the sprocket from moving to the left. Then we obviously have to worry about retaining the bearing because that's has a chance of sliding out. But we're going to worry about that later. So I'm going to quickly make you transparent. I'm going to figure out what size spacer we need. Obviously going to be a standard 1/2-inch hex spacer. What is the distance? The distance is going to be 1¼ inch. So we are going to do the same exact thing that we did last time when we made this standoff spacer. I'm going to drop all of these into their own folder quickly, just so I don't lose track of them. To hide you, I'm going to make our spacer. So I'm going to start a sketch. I'm going to make a inscribed polygon. I'm going to do 6 sides. I'm going to make sure the inner diameter of that inscribed circle is going to be 1/2 inch. Actually, for these, whenever I make custom spacers, these are going to be 3D printed. You have to worry about your 3D printer tolerances. So typically, depending on the 3D printer, and the 3D printers that we use over at the Build Space, we don't tune them perfectly. They're not like my 3D printers where I make sure they're good within 1/1000th of an inch or whatever. I typically add about 5/100ths of an inch. So I set the inner diameter to 0.505, just so I know they will slide on nice and easy. So this is going to be hex spacer profile. It's going to be the sketch name. I just want to make the outer diameter of U about, let's do 0.75. Typically, whenever I do a hex spacer, this is the geometry I'll use. I have a 3/4 inch outer circle and then a inner hexagon with a circle inscribed in it of 0.505 inches. And once you have that, you're just going to extrude it to whatever length you need, in which case ours is 1.25 inches. Now, obviously, we have to edit the appearance. I'll make you orange right now. I don't know why, but I tend to make spacers or 3D printed things orange. Assign the material. Material doesn't particularly matter, but typically we're going to 3D print them out of PLA because that is the most abundant of 3D print materials. And then we're just going to name it. Drivetrain part 005, 1¼ inch spacer. I'm actually going to rename that 1¼ inch hex spacer. Coolio. So with that, I am going to insert that part. HU to the center of U, flip you outwards, rotate you by 90 degrees to make sure you're actually aligned so I don't get interference errors later. Okay, rename you 1/2 inch hex spacer, mate. I'm going to mate. Actually, I think that should be good. Cool. So I'm just going to continue rolling on here. We're just going to assemble these together. I'm going to mate the outside of you. Actually, no. I'm going to mate. Oh, we actually, something we screwed up. We'll have to fix that here in a second. We're going to mate the, yeah. We're going to mate this left area, the output of the PEM nut, to right here. That's going to be gearbox. It's going to be the main gearbox mate. Those two go together. So now you actually have your gearbox firmly attached to your left drive rail. I'm going to do a quick interference check. Seems to be a little bit of interference here. Seems that I have mated my bearing incorrectly. There's also something going on here. I'm going to fix that first because I think these two interferences are tied together. So I'm going to sometimes these bearings can be very finicky, so I'm actually going to delete you quickly. And I want to make sure this inner rim is mated to this outer rim. Bearing. I could just check the interference between the two. No interferences. I run a interference check one more time. Seems to be an interference between something and this gearbox plate. IDU. So maybe this, the West Coast Products bearing block, is interfering with the gearbox plate. IDU one more time. Let's run another interference check. No, something else is interfering. What though? Why are you mad at me?
Wait, how did you connect the gearbox to the actual rail?
I mated the hole where you have that PEM nut. The outside of that is mated to the hole we drilled just to the left of this big hole. So, let me that quickly. I mated this hole right here, this hole right here. Let me run a check. Now I'm not having issues with that. Check something. Outer diameter of U is 3/4 inch. The inner diameter of U is 0.973 or 937. Outer diameter of U is 1.123. Outer diameter of U is 1. Oh, so that's the issue. So this hole here is actually too small for this guy. Is that messed up over here? I messed that up. I found an error in 1678's CAD. Huh. I wonder how they solved that. Well, we're going to have to fix that quickly. So I need to make the size of this hole slightly larger, from 1.115 to at least 1.123. So I'll probably just make it 1.125. Go over here, we go to secondary gearbox plate. main sketch, edit. 1.125. Very minor fix. What was that? 100th of an inch. It is good enough. In a folder. And I'm going to mate again. Hole to that hole. That is going to be the gearbox mate. Those should all be good. I'm going to run an interference check. And we have no interferences other than those tiny areas that we already knew have interference. Cool. Questions?
I think I have an interference on my hex bearing on the rail. I might have just
Let me check.
probably the circle that I clicked.
So let me interference check. So you're talking about these?
Yeah.
So that looks like it's caused by, and this is one of the many annoyances I have with hex shaft in CAD. Notice how your hex shaft is slightly rotated?
Yep.
Um, there we go. You had a 10-degree rotation.
Oh,
Your
that's fun.
So whenever I use hex shaft in Onshape, I make sure I never rotate it because then you run into weird issues with now you're yeah you just have a whole bunch of things that could go wrong. Um, Now I don't know if your gearbox itself, it looks like it's not rotated. Yeah. Um, yeah. Whenever you use hex shaft, make sure it doesn't have a revolute mate, or if it does have a revolute mate, make sure everything else that has a hexagonal orientation with it, like bearings or spacers or whatever, make sure those are also have the same relative mate. Because if you start spinning your hex shaft and you don't spin your bearings, then you're gonna get a bunch of annoying interferences.
I
Oh
think
yes,
it
I have a
still has an interference though.
Oh, it does? Uh, oh yeah, it has a tiny one. I would find out which mate that is and delete it and oh wait. I think you're having an issue with your bearing is not actually mating to the inside surface. See this? There's
Yeah.
a space between that. So I would delete your bearing mate and replace it there.
Okay.
Tanuj, you got a question?
yeah, I have like those really little annoying things like the hex shaft. So how do I fix it?
Let me check. What was the issue?
Like when you run the interference check, the hex shafts don't match
Yeah. So this is the same thing where um, your shaft is unoriented from your the other things you place down. For for the most part, you can ignore these. It's just kind of an OCD thing that I have. So you might want to actually go in here and look at your regular gearbox. You can notice your hex shaft is actually rotated in the gearbox itself. You'd want to find where that mate is, um, and possibly change that. It might be this guy. Yeah. I think here, this hex bearing that you have seems to be rotated a whole lot. Let me change you to 0 degrees. Yeah. So now your hex shaft is orientated straight up and down, basically. And now if you go back over here to your drivetrain, now your bearing and your hex shaft are only misaligned by 90 degrees. So if you find that original mate, which I assume is fasten 1, you just reorient the secondary axis, they might fit together better. Apparently not happening. This might be one of those situations where you, instead of making the bearing revolute, you might actually just make it a fasten mate. But then that causes issues elsewhere. Yeah, this gets into one of those annoying situations where what you actually are doing is you're not really mating the bearing. If you think about like physically building this robot, right? If you take a bearing, you're not just placing the bearing into the this bearing block, but what you're actually doing is you're fitting it onto the hex shaft, and then you're mating it. You're pushing it all the way down to the end of the bearing block. In this case, what you actually might want to do is, if you're worried about, actually keeping the correct mating structure where this is a, revolute, it's able to spin, might want to delete this bearing. I'm going to delete that here for you. What you could do is you can do like a, say a planar mate. Planar mate from one of the sides of the, one of the insides of the bearing to one of the sides of the hex shaft. You could change its limits so it's able to move in the X and Y, but you don't, or it's able to move in the Y, it's able to move up and down the shaft, but it should not be able to move in the X, and it should not be able to rotate in the Z. So now your bearing slides perfectly along it, and then what you could do is you could do a second mate, fasten it into there. Oh, but that's giving me an error. Oh wait, I don't think you'd want to do a fastened. You'd want to do a which one? I literally did this like an hour ago. I was caddying before. Is slider mate? Mate over defines assembly. Why are you giving me errors? Try this. Cylindrical mate. It's don't change the Z, but you do allow that. What? How dare you give me error? Now I'm very confused. There's some combination of mates that should work for this. Just trying to figure out what. These are one of the situations where you'd probably want to mate multiple times in order to revolute in there. Here. How would I keep your orientation with that? I would like a
Could you fasten the two faces or would that?
No, you can't apply multiple fasten mates because a fasten is like a one time. It will fully constrain your mate. Every other mate allows some other axis that you can rotate on, and so you could do multiple of those mates. So you could have like a revolute mate and a slider mate, or a planar mate and a pin slot mate, but you can never have two fasten mates. You could also never do like a cylindrical mate and a fasten mate, or a slider mate and a fasten mate. Issue here is now you have tolerance problems. So maybe if I did parallel mate, make you face parallel to that face. Okay, there we go. That would be the mate that you want. So I put the bearing all the way to the end using a slider mate, or a revolute mate. I put the bearing all the way to the end like you would a fasten mate, but I said you could rotate in any orientation as long as you are touching the face of the bearing block. And then I did a parallel mate between the edge, one of the flat edges of the hex shaft and one of the flat edges of the inside of the bearing brace. So now no matter what orientation you spin this in, those two will orient together. Now you should not have any interference issues. Well, you don't have any with the bearing now. Now you're having it with your hex spacer. So you'd probably want to do the same thing. Now you can avoid all of that if you just keep your hex shaft straight. And that's one of the reasons why, for a lot of things, I don't like giving revolute mates to hex shafts, because they always end up being annoying um, with uh, with things later. They always get in the way. So if you can avoid using revolute mates on hex shaft, then do it. Just fasten mate it and it should be good. Even though that's not technically correct, you're not gonna. I can't think of a situation where that would be an important thing inside of Onshape. Okay, other questions?
So, I still can't figure out what I'm trying to mate.
For the
I keep clicking
gearbox?
on all the holes. No, for the hex bearing.
Uh,
Acting weird.
okay, so what this hex bearing?
Yeah.
Okay, so what you want to do, show mates here, fasten one. So as you notice, there's an inner lip here on the bearing block, and you have this outer thing that has a diameter of 1.25 inch, which matches the diameter of this almost. And then you have that inner lip, and so what you're doing is you are mating this surface, this flange of the hex shaft or the hex bearing, to this inner lip right here. So the bearing can't go any further in. That's the entire point of having the flange there, is to retain it so the bearing can't go any more in that direction. So what I was doing a fasten mate. This flange is grabbing the center, but relative to the circle of this flange. Then I'm going to grab this outer rim right here, center of that. That is my 1/2 inch hex bearing. And I might have to rotate that 90 degrees to get it with the rotation. There you go. So now your bearing is good.
I still have interferences though. Wait.
Let me check. Having interferences because having
But
interferences.
without the
That's because the hex shaft is slightly rotated. Try something. Yeah. You're having the same issue Tanuja was having. So if I fix the drive rail here, I can actually physically grab and turn this. In which case you wouldn't want to do you would want to do the same thing that Tanuj had to do. So you'd want to do a revolute mate on the bearing. The bearing can rotate, and then you'd want to do a parallel mate between one of the flat edges of the hex shaft, one of these flat edges or flat insides of the hex bearing. So now they rotate together. Now you shouldn't have any interference.
Yep, it's good now. All right.
So this is just one of those things that you'll pick up more and more over time as you use Onshape more and more. You know, if you want to fully constrain something, you can either use a fasten mate or you could use combinations of other mates to achieve your final goal. The more realistic you get, the more just kind of work you have to do. You could do this with a single fasten mate, but then you wouldn't be able to rotate your hex shaft and your bearings wouldn't rotate and stuff like that. So like I'm actually gonna fix that over here. Mine, because my hex shaft, yeah. My hex shaft will do that too. Or a revolute mate. Do a planar, no. Parallel. Half-inch hex bearing. Those will all rotate together. Cool. So that's that. Let's get some more stuff going. Let's get some more stuff cooking here. We spent a lot of time on that. I want to finish up a few things here before the meeting ends. The main thing I want to do is we did not finish some things with relation to the gearbox, and that is the bolts. So a lot of people would take the arrogant approach and be like, oh, bolts, like you don't have to CAD those in. But as you all might be able to notice, there's actually some very big important issues that might happen if you don't CAD in your bolts. For example, look at how we mated the gearbox. So if we have the gearbox so that we could put a bolt through here, go through the rail into this PEM nut. That's great, like whatever. But look down here at this little hex shaft, or not hex shaft, this little spacer that we have. There's supposed to be a bolt that goes through this hex spacer and anchors into this sim motor or mini sim. But where would the head of that bolt go? It's going straight into the drive rail. And so what you would end up having happen is if you assembled this gearbox and then went to attach it to your drive rail, those bolt heads would get in the way. And you would be like, oh crap, I didn't CAD in the bolts. Thus, I wouldn't have noticed that issue. So let's go ahead and CAD in the bolt, and then we can figure out how to address that issue later. I don't know what style of bolts those actually takes. Let me look this up on Vex. Joins. They take 10 30-second bolts. So we need a 10 30-second bolt that is at least 2 inches long. So I'm going to go up here to, again, I'm inserting in the gearbox assembly. Going to ANSI inch bolts. I like using socket head screws because those are my favorite. We're going to use what, 10 30-second was it? Yeah, 10 30-second. Length, I'm going to do 2 1/4. And I'm going to insert a few of those right along here. Nice. So I'm going to insert 4 of these because we'll need several. Insert all of those along there. Now I need to rename those, so I'm going to just rename those quickly for the fasten mates. Just 10/32, 2.25-inch bolt. Copy that and rename those 4 fasten mates I just made. Also, apparently 2 fasten mates that I didn't rename, and I should figure out what those are. Ah, those are the PEM nuts. PEM nut. PEM nut. It might seem tedious and trivial to rename all of your mate features, but trust me, it would, it's going to be a lifesaver when you're, CADing with 10 other people and walk into an assembly and you just see 22 different fasten and revolute mates and you're like, how the hell am I supposed to fix this? So please make sure you're up to date, keeping your mates nice and organized. There are 2 other bolts that we need to put in because there's 6 motors. Each of them have 2 bolt holes. I only put in 4 of them. Those are actually hidden back here. So if I make this spur gear transparent, you can actually notice there are space for 2 more bolts. So I'm gonna go insert. I want some 1/2-inch bolts. So I'm gonna click on you. I'm gonna click on you. Insert. Now insert 2 extra bolts. And because this gear is pocketed, even though it looked like you might have interference here, you're actually not because there's space inside of that. If I hide these, yeah. Because of that pocketing, you actually have some space where that gear is actually not going to touch the top of those bolt heads. You could use lower profile bolt heads as well. I just really prefer these socket ones because they're so easy to take out. So I'm going to rename those quickly. Those are number 10, 32nd, 0.5-inch bolts. Okay, so you throw in all those bolts. You come over here and you look at your assembly and you run an interference check. You include your standard content, as you always should. You realize, oh crap, the top of my bolts are hitting the inside of the drive rail. I need to fix that. Ignore these. You will always have interference on these things where wait. Ignore the interference inside the motor because you're threading into the motor, and as long as you know that the mounting hole on the motor is the exact same as the dimension of bolt you're using, you're fine. What's concerning me is that there's interference on the metal here. There's something I need to check. Number 10, 32nd bolt diameter. Diameter is exactly 3/16 of an inch. Size of these. Ew. I think these holes are a little bit too small. Because 3/16 of an inch is 1.196, and these are 1.191. I might actually go in here and fix that quickly.
For the long bolts, I inserted the wrong head type by accident. So what was the dimension for the length?
Uh,
I have to read
2 1/4.
Okay.
Oh, what
Um,
was the like dimension for the little bolts and like
uh,
inside this?
those were half inch.
Okay, thank you.
These. Yeah, so I definitely need to make these. Sure. I don't know why I made them so small previously. I'm basically just going into the sketches and just increasing the size up to 0.196 for all of these. Hopefully that won't cause any interferences later, but I guess we'll find out. Nope, no issues. All hole sizes need to be changed to 1.96. 0.196, sorry. For those outer mounting bolts. If I
Where are we
run,
putting those small bolts again?
the small bolts go on the left and right motor on the um, innermost attachment point. They're kind of behind the spur gear. You can only see it if you hide away the spur gear. I'm gonna let you all finish that up quickly. I need to run to the restroom, so I'll be back in a minute.
Janusz, do you have the dimensions for those small bolts?
Small what?
The small bolts?
Bolts are same, but they're 0. Like half an inch.
Okay.
Big.
Because we just sped up and I was like, oh shoot, these are the wrong type of heads.
Wait.
Do you know why Sahil added us all to this group chat?
No clue. I
We're
was
all
about to
gonna be
ask it.
doing video for now on
Rip business model.
business model's almost done.
Is it though?
Yeah, we just need to add like cost.
Yeah, but we have to write it. Like it's not good. Like
Yeah,
it's
but
good,
it's like
but like
3 sentences.
no. We have to like go through and make sure everything is it's written well.
Yeah, but that's the easy part. Having it written is the hard part.
I mean, in a week we'll be free if we don't make it. Then.
I have no idea what y'all are talking about.
Talking about the
The
business
business
model.
model.
Ah, yes. I kind of hope we don't make it to semifinalists because I really don't want to worry about getting all this stuff submitted by next week. That's just going to be nerve-wracking. But
Yes, we are all very stressed.
uh, such is first. So have you all gotten all these things in, and you're passing an interference check on your gearboxes? I'll take that as a yes.
I am, yeah.
Okay,
I'm in
cool.
the process.
So I would just kind of move on a little bit quickly. Um, gonna quickly do another interference check. Look for issues that will have errors. Don't really see any. There's some minor things, trivial things. You're obviously gonna have your interferences in your sim motors where you're threading into. Don't worry about those. You're gonna have interferences with these gears. We know that spacing is correct. Having like these shoulder tiny little interferences on some of the bolts, that doesn't matter. That's like it's not going to interfere with anything. Obviously the PEM nuts are going to interfere. That's kind of the point of them. um, Key thing here is that there are interferences with these bolt heads. So what we need to do is we need to drill a hole into the side of the rail that can allow for clearance of these bolt heads. What I'm going to do, I'm going to look at the diameter of the bolt head, and that is about 0.312. So let's say 3/8 of an inch. That's how big of a hole we need. And we need it to be 3.1 inches away, the left or right of the main center hole. I'm going to go back here. I'm going to look at my left drive rail. Open up the hole sketch that we were doing. I'm going to make a 0.375 inch hole. I'm going to put it 0.31 inches away. I'm going to make it horizontal with that center hole. I'm going to mirror it across using that mirror center line, and that's going to cut out another large hole there. And that should, yep, that gives me clearance for the bolt. And now I can even tighten it through there if I needed to. Actually, now that I think about it, that doesn't need to be a through hole. That just needs to be a single-sided hole. Doesn't matter. That's how we're going to do it. Okay, well, that is that for today. I think I will end it there. Um, I was hoping we might get to the other gears, or sorry, the rest of the wheel, so we could finish up the drive rail today. It doesn't look like we will have time to do that. Um, so, do any of you have questions before we end the meeting here?
Could you check my interferences
Yes.
real quick? Because I'm not sure what's supposed to be there anymore.
Check interferences. This does annoy me. Makes me want to go through and get rid of a lot of these interferences. The main source of interference that annoys me is these freaking sim motors whenever you thread something into them. So the main interference issue that you're having is you're having interference between your bolt and your plate. So you need to make those larger. So go into your part studio and increase the size of these holes where you have the bolts going through to 3/16 of an inch. That will get rid of a lot of those.
inner diameter, right?
Yes.
Okay. Are you sure it's 3/16? Because that just made more issues.
More issues. How so?
More interferences. It made the hole smaller.
Make sure you're switching the. It should make the hole bigger. Make sure you're doing the inner hole, not the outer hole.
Yeah, the inner hole. Before it was. Let me check. Oh, now I can't change it anymore.
Currently, it's 0.159.
Oh, on that plate? I thought you meant the spacer.
No, no, not the spacer. Yeah, change all those, and that should be good.
Wait, so what was the inner diameter of the spacer then? Because then I have to change that back.
That should be 3/16 or larger. I think I actually have mine as like a 1/4 inch or something. Mine's a 1/4 inch.
Okay.
So on that note, next meeting, what I'm gonna try and have us accomplish is we are gonna put in the bearing blocks for both the front and back wheels. We're gonna put in some custom chain. We use a chain feature script, so we actually have really nicely rendered chain. We're gonna put in the middle wheel and all the omni wheels on either end, and we will have the entire left block done. And if we have time, we need to replicate it over and do the exact same thing for the right rail. Where we just have basically invert everything. And then we'll have, then it's trivial to just add the front rail, the back rail. We'll design a belly pan, and then we're done with the drivetrain. So we're getting closer. Hopefully, we should be fully done with the drivetrain within the next 2 meetings. But other than that, if you all don't have any questions, I'm going to go ahead and sign off for tonight.
Wait, what is changing to 3/16? I'm sorry, I'm just going crazy.
You're changing these holes right here. Are you looking at my screen?
Yeah.
So these holes you want to change to 3/16. Anywhere those 10 30-second bolts go through. So you have 6 holes on this plate that you need to change to 3/16.
Oh, I am over defining it now. Okay.
It should be just as simple as changing the number, changing the dimension, but hopefully that doesn't give you other errors.
I'm trying to find where I put the original dimensions, but I can't find it.
Okay, Tanuj, yours looks good. Cool. Well, in that case, I'm going to go ahead and get off. Aiden, I trust in you to get that finished. Um,
Alright.
yeah, I believe in you. Other than that, I will see you all at the regular meeting tomorrow.
Alright. Thank you.
See y'all. And I'm going to end the stream, not stream, the recording there.